So, ladies and gentlemen, this will be a take two for those of you who are in my chemistry class just now. For your copper carbonate lab. Now, one of the things we really want to teach is how to do data processing using a spreadsheet, whether it's Excel or Google Sheets, because in the future, when you're doing your IA, you need to crunch about 25 trials, and if you're biology, even more. So in this case, I want to teach you guys that skill so that later on you can actually just quickly get it done easily. So now, previously, I shared with you through Hapara this spreadsheet. So it's just 1.3 molar mass of a gas. You should only have these two right now. Now, what I want you to do is to add the more headings. So I'm going to flip to the one that I have. So you should have a you should have these numbers, okay? So mass of reactant before, and I demonstrated in class if you want to make sure that this line goes to next, this goes to next line, what you should do is on your Mac is command return. It will add one more line there, okay? So make sure you do that for all your headings and units. Try not to use brackets. The IB preferred using slash rather than bracket. It's funny like that. So here I'm going to fix it too on mine, and your R also. Okay. So make sure you have the following headings. Okay. You might need to pause your videos so that you can actually get these numbers. Okay. So make sure you have these headings. Don't worry about this pressure and don't worry about this number. Okay. Now R is 8.31 and accepted value is 44.01. So feel free to pause your video to have all these headings. Okay. Now at this point, well, I'm going to be assuming that you have all these headings in already. So now, because in chemistry, we need to propagate our uncertainty. In biology, you don't. So let's focus on the measurements first. So in this case, let's hide this. So you select this. This lesson is really almost like a lesson on Excel spreadsheet or spreadsheets. Right click, hide the column. So just hide all the uncertainty columns. I'm going to deal with that one thing at a time. Okay. Hide. Hide. Okay. Hide this. Hide this. All right. So I think I hide pretty much everything already. So for this experiment, if you remember correctly, we are just expanding this so it's all. So for this experiment, I'm just going to make up some data. So let's just say 0.33 grams you start off with, and later on it was 0.24. So you can see that I calculate this here. Rather than using a calculator, you can let's just erase this part first. Rather than using a calculator, I can just do equal. Remember, it's this cell minus this cell, right? B2 minus D2, that's the name of it. Now, when you click enter, it will calculate for you. And one neat thing about it is that it will, if you change the number, let's just say, oh, it's actually 0.25, it will change the calculation for you. And this is a beautiful part. If you take this, go to the corner and drag down, it'll do all these calculations. So let's just say your next trial is 0.32 and the other one's 0.16. Let's just say 24. See, it will calculate it for you also. So imagine if you have 25 trials to crunch. This is actually a game changer. So make sure you figure out how to set this up. So again, it's a drag down. Okay. Now pressure. Today's in-class pressure is 101, 100.10. Room temperature is roughly about 23 degrees. So in this case, you have to put it in Kelvin. So again, if you remember correctly, your degrees. So let's just say it's 21 degrees Celsius. 21 degrees Celsius plus 273. So that will be the temperature in Kelvin. Your volume. So let's just say it's 34 decimeter cube or centimeter cube. Okay. So again, this unit here is decimeter cube. So what you need to do is equals 34. Because it's 34 mils, you have to change it to liter. So 34 or 34 centimeter cube to decimeter cube. So it's divided by 1,000. It'll give you this number. Now I forgot to hide this column, so hide that. Now to calculate the experimental molar mass, how you do this? You might remember that PV equals nRT. PV equals nRT. Now, however, PV equals nRT, but you don't have the molar mass here. But you do remember that N equals mass over molar mass. So in this case, let's just substitute this whole thing in here right now. So you have a mass equals molar mass RT PV. So in this case, you just want to isolate this thing here. So in this case, you have molar mass move to here, and P and T get divided. So P and V here. So you have mass RT. Does it make sense? So to find this here, you have to have your mass of the CO2 times the mass times the R value times T divided by P divided by T. Oh, look, all these stuff are here. So this here would be your mass, which is this cell here. Now, oh yeah, put a bracket on it first. It's gonna, your bed mass won't get accidentally messed up. So bracket F2 times, now times on computers usually this star, times R, which is here, times T, which we have here, close the bracket, and then divided by bracket P pressure times volume. Close the bracket. So if you double check, F2, which is here, the mass of the gas, pressure, it was not pressure, R times R, which is here, T, which is the temperature in Kelvin, L2, good, divided by P, so P is here, I2, times V, which is volume, so it's here. Good. So let's press that. Oh, it's 57.4. So if that's my molar mass, and this is the accepted value for the gas, because gas of CO2, it's one carbon plus two oxygen, which is 32, so it's 44. Yeah, I have a I have an error of minus 30. And how do I do that? Again, if you look, percentage error is your V2, your accepted minus your experimental. So V2, this cell minus this cell, divided by your accepted value. And turn into a percentage, it looks like this. Okay? So I'm going to delete all this here. So again, once you have this set up, you can just drag this down. So let's say next one, if I have 33, let's just say if I use up, have this data again, and let's just say pressure and temperature didn't change. Oops. Pressure and temperature didn't change, but the volume this time is, let's just say it's 35 mils. So 35 milliliter divided by 1,000. So it will automatically calculate it for me. So this is how you would calculate it. This is how you set it up. Now pause, ask me questions, ask me or your teacher questions. So this will be how to calculate the experimental molar mass uh, using Excel as well as a calculation percentage error. Now we're going to deal with the uncertainty, and this is the fun part. Now we're going to do one at a time. Now the uncertainty, now we use the electronic scale for the uncertainty. So in this case, uncertainty is our scales are two decimal place, which means it will be plus or minus 0.01. Oops, not this here. 0.01. And our mass after is also using the same scale, 0.01. So in this case, our absolute uncertainty, because yes, we kind of add, we kind of subtract these two, but we do have to add these two uncertainty together. If you remember your lesson on uncertainty, so this here is again C2, this cell, plus E2 right here. Okay, and my relative uncertainty, if you remember this correctly, would be my absolute uncertainty divided by my measurements. So that will be 25%. Good so far? So again, the good thing, the cool thing about doing these things on Excel and learning how to do it is you can have this formula, drag it down, and next time it will be pretty much the same thing too. By the way, since you're using the same scale, you can just drag it down. It will do the exact same calculation. Okay? Now, uncertainty. So pressure, the uncertainty. Now, for this one, because our air pressure sensor is two decimal place, so again, 0.01, the relative uncertainty would be this divided by this cell here. So in this case, 0.01%. For temperature, now you use a thermometer. So the thermometer, if I remember correctly, is 1 degree difference. So it'll be plus or minus 0.5 degrees. Then your relative difference would be this divided by this would be 17%. Again, your volume, your odometer is by milliliter, so it's point. So essentially, it is 0.5 mils divided by 1,000. You have that. So your relative uncertainty would be this cell here divided by your measurements. Okay. Now we've done all this calculation. Now, your percentage uncertainty for your experimental mass, because you actually multiply all these numbers together, you have to add up all the percentage uncertainty. So in this case, you have here Q2 percentage for the temperature is this one, plus the pressure for this one, plus the mass uncertainty, this one. So you end up having a percentage uncertainty. So as you see, H2, 25%, Q2, K2, N2, and Q2. So you add them all up together. Now you have to convert this back to absolute uncertainty. So this one, how you get this is essentially you have to 26.65% times this. So it will be this times this. That will give you the absolute uncertainty for your experimental molar mass. Okay. So you do need to have this to conjugate these uncertainty when you come to your answer. Now, if you're not sure about how this works, make sure you look at the video again or come and ask me or Miss Aragona, and we'll be happy to help. Okay, I'll turn this thing off.